So in this video, I'm going to introduce you to the one sample mean and what we call our central limit theorem. And again, this is based on sampling distributions. And we've talked about the sampling distribution for the proportion, for one proportion, and also for the difference in two proportions. So we're going to move to the mean now. And the learning intention today is you're going to explore sampling distributions of the sample mean. So when we talk about this, we're talking about what's called the sample mean. And remember, we give the sample mean a special name using the central limit theorem. So the sample mean itself is called x bar. Remember that. So when we talk about our sample mean, we're talking about x bar. We'll cover that again. But here you should be able to find the sampling distribution of the sample mean, which again is referred to as x bar. Identify the mean of a sampling distribution for the sample mean. Identify the standard deviation for the sampling distribution of the sample mean, and calculate the normal probabilities from the sample mean. So let's introduce this with an example. And in this example, there's a small startup company that has these 4 employees that work for it. These are all the 4 employees that work for this. So this is the population of this company. And here's their experience working with this company. So you have Alice, Brandon, Chris, and Debbie. They have 1, 3, 5, and 7 years respectively. What I want to do, though, is I want to find the mean value. And in particular, I want to find the sample mean from a size of 2 with replacement. And what that means is I'm going to put these names in a bag, draw a name out, and then put it back in, and then draw a name out again. Get their years of experience and find the average between those 2 values. So I've already started this by saying, well, the first person I drew out was Alice, who had 1 year of experience. Put her back in, shook the bag up really well, drew it out again. It was Alice again. So if I find the mean for that, the mean would be 1 plus 1 divided by 2. 1 plus 1 is 2, divided by 2 is just 1. So let's say we do it again where Alice comes first, but this time we're going to pull out Brandon, the second smallest. Finding the mean, the sample mean, which is your x bar here. These are your x bars that I'm finding. They're all sample means. If I do 1 plus 3, I get 4, and I divide that by 2, I get 2. Next one, Alice and Chris. 1 plus 5 is 6. Divide that by 2, that's 3. And then finally, Alice and Debbie. 1 plus 7 is 8. 8 divided by 2 is 4. These are all the samples where I can pull Alice first. Now I'm going to repeat that process, but this time I'm going to pull Brandon first. So when I pull Brandon first, I can pull Brandon and Alice, or Brandon with Brandon again because I'm replacing him, or I can do Brandon and Chris, or I can do Brandon and Debbie. And if I find these sample means, 3 plus 1 is 4, and 4 divided by 2 is 2. 3 plus 3 is 6, and 6 divided by 2 is 3. 3 plus 5 is 8, and 8 divided by 2 is 4. And 3 plus 7 is 10, 10 divided by 2 is 5. These are all the possible sample means, or all the possible samples where I pull Brandon first. Repeating that process with Chris next, I can pull Chris, who has 5 years, with Alice, Chris and Brandon, Chris with himself, and then Chris with Debbie. And again, if I find these means, notice the pattern here. This will just be 3, 4, 5, and 6. And then finally, if I pull Debbie first, so I can do Debbie and Alice, Debbie and Brandon, Debbie and Chris, and Debbie with herself. Finding these means, this is just 4, 5, 6, and 7. So by doing this process now, what I want to do is I actually want to graph these sample means into a dot plot. So I'm going to graph these sample means into a dot plot. And I'm actually going to tell you that when I graph these, instead of using dots, I'm going to use x bars to represent sample means. So how many times do I see the value of 1 here? Well, I only see it once. How many times do I see the value of 2? Well, I have, let's list all the ones for Alice first. I have 1, 2, 3, and 4. Then I have 2, 3, 4, and 5. Then I have 3, 4, 5, and 6. Then I have 4, 5, 6, and 7. And something interesting is happening here. Notice that the value that is occurring the most is sitting at the center of this distribution. And as you move away from the distribution, it gets smaller and smaller in quantity. And notice also that you have exactly the same on the left as you do on the right. And remember, If we draw a curve over this, we can see that this is a normal or symmetric distribution. It's normal, actually. It's the bell shape. And this does not happen by coincidence. And if we do a couple things, we're going to see that when, first off, if I want to find the mean, the population mean, we call the population mean mu of x. That's what this stands for. Mu being a Greek letter, x's being the x's you're looking at, all these different x's. Your x's are actually 1, 3, 5, and 7. If I want to find mu of x, I'm going to add up these values here and divide by 4. Well, when I add these up, I get mu of x is equal to 7, 5, 3, and 1 is 16. 16 divided by 4 is just 4. So the mean of x is just 4. If I try to find the next thing, which says the population mean, mu, of the sample means, x bar. So I want to find the mean of all these x bars, or all these x bars here. I'm going to add those all up. And when I add all these numbers up, so if I add up 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, add all that up, the mu of x bars are equal to 64, and there are 16 total x bars there. That's also equal to 4. Notice what occurred. The mean of the population is equal to the mean of the sample means. The mean of the population, this 4, is equal to the overall mean, the population mean of my sample means. And we can also find the standard deviation of this distribution. And we do that by using our list in our calculator. And we'll go back through that later. But the standard deviation for this particular distribution is 2.236. And remember, this is the population standard deviation. And so this is the standard deviation for this. Remember, we call the standard deviation, this is sigma x. And that's equal to 2.236. Now, it just so happens then that this population standard deviation for all of these sample means can be found by using this population standard deviation and dividing it by the square root of your sample size. And remember, our sample size here is n is equal to 2. That was our sample size, n equals 2. So if we do 2.36 or 2.236, and we divide that by the square root of 2, we're going to get 1.581. And we can show both these standard deviation values by plugging them into your Inspire. And to do that, you're going to look at your list again. So I'll make a separate video on how to do that. But right now, all we want to establish now is that the mean of this distribution is centered here, and it's centered at the center of the x bars as well as the population. And the other thing we want to establish is that the standard deviation of the population, when you look at a sample, it gets smaller. So we went from 2.236 to 1.581. This tells me that as my sample is increasing, the variation is decreasing.